Alright, in this video we're talking about 3.2 probability distribution and for the probability distribution for discrete random variables. First of all, let's take a look at the definition. What is the probability distribution? The probability distribution or probability mass function, shorthand version is PMF of a discrete random variable. It is defined for every number x by the probability of this possible value is equal to the capital P, which represents the probability of the random variable is equal to this particular value. So which is equal to the probability for all possible outcomes in the sample space such that the x of s is equal to this particular value. So actually the definition looks a little bit abstract. Let's take a look at example here, and I believe this example will make everything clear. So toss a fair die. Now if we toss a fair die, first of all tell me, so what kind of possible values we could have? So x could be 1, 2, 3, 4, 5, and 6. Right? Because we're tossing a fair die. Now let's take a look at probability. So when we're talking about when we're thinking of the probability, we always thinking of the formula P of A is equal to the frequency of A divided by the total. Okay. Now what's the total here? How many different numbers we have? We have 6 of them, right? And then what's the probability of 1? 1 over 6, and then 1 over 6. And the probability of 3 is 1 over 6, and the probability of 4 is 1 over 6, probability of 5 is 1 over 6, and this is 1 over 6. And we call this table the probability distribution. That's the probability distribution. So in other words, if you want to build up a probability distribution, you need to list all the outcomes of the random variable. In this case, we get 1, 2, 3, 4, 5, and 6, and then you need to find the probability of each possible outcome, and this will give us the probability distribution. And there are two propositions I would like to mention. Number one, that the probability of any possible value is always between 0 and 1. Each probability over here always between 0 and 1, inclusive. Number two, the sum of all probabilities in the probability distribution is equal to 1. So basically, if you add them all up, so 1 over 6 plus 1 over 6 plus 1 over 6 plus 1 over 6 plus 1 over 6 and then plus 1 over 6 will give us 1. The probability of the sum of all probabilities in the probability distribution is always equal to 1. And this is super important. And that's how we identify if a distribution is a probability distribution. We just need to say if those two conditions are satisfied or not. If each probability in the probability distribution between 0 and 1 and the sum of all probabilities is equal to 1, we see this is a probability distribution. Okay? Now, once this makes sense, let's take a look at one more example. This is from the textbook 3.8. 6 lots of components are relatively shaped by a certain supplier. The number of defective components in each lot is as follows. So we got the lot number over here. We got number 1 through number 6. And we have the number of defectives of each lot over here. So the problem says let x be the number of defectives in the selected lot. Build up the probability distribution of x. So since we want to build up the probability distribution of x as what I mentioned previously, we need to list every possible value of x, right? And then we want to find out the probability of each possible x. Now, first of all, let's take a look at what kind of values x could be. So based on since x is the number of defectives, right? So we just take a look at the second row over here. So x could be 0, 1, and 2. So we get x is could be 0, 1, and 2. And then we want to find out the probability of each x. Let's say p0. So based on the definition, we say that there's a probability that x is equal to 0. Now, when we think of the probability, we always think of this form: P of A is equal to the frequency of A divided by the total N. So which means this probability here is going to be equal to the frequency of 0 and divided by the total number of lots. How many zeros we have? We get 1, 2, 3. We get 3 zeros, and the total is 6. And then this is 1/2. And then let's take a look at the P of 1. P of 1 is equal to the probability of x is equal to 1. Now, let's just think of this formula over here. How many 1s we have? We get only 1 over here. So that would be 1 over 6. And we don't have to simplify it. Number 3, the probability of 2. This is equal to the P of x is equal to 2. Now, how many 2's we have? We get 1, 2 of them. 2 over 6 is total 1/3. Now we get the probabilities of each possible value. We can just put them here. We got P here, and the probability of x is equal to 0 is 1/2. The probability of x is equal to 1 is 1 over 6. The probability of x is equal to 2 is 1/3. And this table is the probability distribution. Okay, and of course we can check if this is qualified to be a probability distribution by saying if those two propositions satisfied or not. Now, first of all, let's take a look at if every probability in the probability distribution between 0 and 1. Yes, all three of them are between 0 and 1. And then let's say if the sum of all probabilities is equal to 1, so we add them together, 1 over 2 plus 1 over 6 plus 1 over 3. So that is equal to, of course, we want to find the common denominator over here, which is the 6. So that would be 3 over 6 plus 1 over 6 plus 2 over 6. So which is equal to 6 over 6, which is equal to 1. So of course, this is the probability distribution. Okay? And that's how we identify if a distribution or if a table is a probability distribution. We just need to check if those two conditions are satisfied or not. If they are, then it's a probability distribution. If they're not, or either one of is not satisfied, then it's not a probability distribution. Okay, now once this makes sense to you, let's take a look at this example 3.9. So consider whether the next person buying a computer at a certain electronics store buys a laptop or desktop model. Let x is equal to 1 if the customer purchases a desktop computer. X is equal to 0 if the customer purchases a laptop computer. So the problem says if 20% of all purchasers during that week select a desktop, from the PMF and the probability distribution. So in this example, I'm going to show you how to find both the PMF, which is probability mass function, and the probability distribution. So same thing, if we want to find whatever the PMF or probability distribution, we need to find all of the possible values of x and then find the probability of each possible value. So in this case, x could be 0 and 1. And then what's the probability? So the P of 0 is equal to the probability of x is equal to 0. So what's the probability of x is equal to 0? X is equal to 0 means the customer purchased a laptop, right? And the problem says that 20% of all purchasers during the week select a desktop. Then that means the P of 1 is equal to probability of x is equal to 1 is equal to 0.2. Because x equals 1 represents the customer purchased a desktop computer. And we know 20% of the purchasers during the week select a desktop. So the probability of x is equal to 1 is equal to 0.2. right? And we know that there are only two possible outcomes, 0 and 1, and then the probability of x is equal to 0 would be equal to 1 minus p of 1, which is 1 minus 0.2, which is 0.8. Okay? So if you want to build a probability distribution, that would be x could be 0 and 1, and the probability of x is equal to 0 is 0.8, and then probability of x is equal to 1 is 0.2. And this, oops, sorry about that. Let me pull out the mark. There we go. So this table is the probability distribution. Okay. Now the PMF. The PMF. Okay, so for the PMF, we gotta write down the P of x is equal to, and then we need to list the probability of each possible outcome. First of all, 0.8 if x is equal to 0. 0.2 if x is equal to 1. And then 0 otherwise. You cannot miss the last part over here. You gotta tell people that if the probability x is equal to any other number, it's equal to 0, okay? Because x can only be 0 and 1. So the probability x is equal to any other number outside of 0 and 1 is equal to 0. So you cannot miss this part, okay? Now, this is how to build up the probability distribution and the PMF. So, same thing for the probability distribution. First of all, you want to find out all of the possible outcomes of the x, and then find the probability of each outcome. And for the PMF, so once you find all of the possible outcomes and the probabilities, so you just put them together in this form. P of x is equal to, and then the probability, and then corresponding x value, probability, the corresponding x value, at the end 0 otherwise. Okay, and this is very important. Okay, this is very important, and you will definitely say something about this in homework 4 and in the first midterm exam. Now let's take a look at example 3.10. Consider a group of 5 potential blood donors, A, B, C, D, and E, of whom only A and B have a type O positive blood. 5 blood samples, 1 from each individual, will be tapped in random order until an O positive individual is identified. So we get 5 people in total, and 2 of the have the O positive blood. Now, let random variable y is equal to the number of typings necessary to identify an O positive individual. And then we want to find the PMF of y. Now, so as what we went over previously, we know if we want to build up the PMF, we need to list all of the possible values of y first. Now, let's think of what kind of values y could be. So y could be 1, right? Because we have 5 people in total. Now, I will write it down first. Y is equal to y is equal to 1. That means the first one is O positive. And y could be 2. That means the first one is not O positive, the second one is. Y could be 3. That means the first 2 are not O positive, but third one is. Y could be 4. That means the first 3 are not O positive, the first one is. And then could y be 5? I don't think so, because we have 5 people in total, and we know that 2 of them are O positive, and 3 of them are not. So if the first 3 are not O positive, that means the first one must be O positive, right? That because if the first 3 are typed not O positive, that means the 2 left, both the 2 left are O positive. That means the first one must be O positive. Okay? So y could only be 1, 2, 3, and 4. And then we want to find the probability of each of them. So once again, if we want to think of the probability, we think of the formula P of A is equal to frequency of A divided by the total. That's what we want to think of. First of all, let's take a look at 1. P of 1. So that would be the probability of y is equal to 1. Well, probability of y is equal to 1. So what does it mean? What does it mean by saying y is equal to 1? That means the first type is O positive, right? That means the first person type could be A or B, because A and B are the two people who have the O positive plot, right? So this is equal to the probability of A or B, tap the first. What's the probability of that? So we think of this formula here. How many people we have in total? 5. And how many A or B we have? We have 2 of them, right? A and B. So the probability is 2 over 5. And then let's take a look at the probability of 2. So that means the probability of y is equal to 2. Oh. Y is equal to 2. So this is equal to the probability that, so y is equal to 2 means that the first one is not O positive. That means the first one is coming from C, D, or E. And the second one is O positive. That means the second one is from A or B. So we're going to have C, D, or E first, then A or B. And we know that they are independent of each other. They are independent of each other because the blood types of each of them is independent of the blood types of all other people. So this would be equal to the probability of, say, D or E times the probability of A or B. Now, what's the probability of C, D, or E? That would be 3 over 5, right? We have 5 of them in total, and C, D, or E are 3 out of 5. And then times the probability of A or B, so that would be 2 over 4. Why is 2 over 4 over here? So after the first type, how many people left? We get 4 of them left, right? 4 of them left after the first type, and 2 of them are O positive. So the probability would be 2 over 4. So this would be equal to 0.3. And of course, this is equal to 0.4. And then let's take a look at P of 3. P of 3 is equal to probability of y is equal to 3. So what does it mean by saying y is equal to 3? That means the first two are not O positive, but third one is, right? That means the first 2 are coming from the C, D, or E, and the third one is coming from A or B. So that would be equal to the probability of, say, D or E first and second. Then A or B. Now let's think of this one by one. So if the first one is not O positive, now how many people we have in total? For the first type, we get 5 of them in total, and 3 of them don't have O positive. So that would be 3 over 5, right? And then after the first type, how many people left? After the first type, the 4 people left, right? And how many of them don't have O positive? 2 of them. So the probability would be 2 over 4. And then let's think of the third type. After the first two types, how many people left? 3 of them left, right? Now, how many of them are O positive? 2 of them are O positive, right? So times 2 over 3. And then this is equal to 0.2. And then let's take a look at a P of 4. That means the probability of y is equal to 4. And then that would be equal to the probability of, say, D or E all done first. Right? The first three types are all coming from C, D, or E. Now let's take a look at how to find this probability. So this is equal to, let's think of it one by one. So first type, how many people we have for the first type? 5 of them. And how many of them don't have the O positive? 3. So the probability would be 3 over 5. Secondly, after the first type, how many people left? 4 of them left, right? And how many of them don't have O positive? 2 of them, right? After the second time, how many of them are left? 3 of them are left, right? How many of them don't have O positive? 1 of them don't have the O positive. And then after the third type, how many people left? 2 of them left, okay? And how many O positive we have? 2. Both of them are O positive, times 2 over 2, so which is 1 actually. So this would be equal to 0.1. Now once we get all of the probabilities and the possible outcomes, so we can say that the PMF P of x, of course y could be 1, 2, 3, 4. P of x, the probability is equal to 0.4 if y is equal to 1. If y is equal to 1. And then 0.3 if y is equal to 2. If y is equal to 2. And then 0.2, I'll write down here. And then 0.2 if x is equal to y is equal to 3. And then 0.1 if y is equal to 4. And then 0, don't forget that otherwise. And that's how we find the PMF, okay, of a distribution. So basically, if you want to find a PMF of a random variable, just first of all list all of the possible outcomes, and then find the probability of each possible outcome over here. And then put them in the form of a PMF. P of x is equal to the probability and then the corresponding function value. Not the function value, the possible outcome, possible values of the random variable. And then don't forget this part, the last part. The probability would be equal to 0 otherwise. Okay. I hope that makes sense to you. And then let's take a look at this part here, a parameter of a probability distribution. So the PMF of Bernoulli random variable x in example 3.9, which is the one we just went over here. So we know that one probability is 0.8, another one is 0.2. So let's take what it's talking about over here. So the PMF, the Bernoulli random variable, the reason why it's called Bernoulli random variable is because that the only possible values of x could be 1 and 0, and that's it. There are only 2 possible values for the x. They are 0 and 1. So we call this kind of random variable Bernoulli random variable. Okay, the PMF of the Bernoulli random variable x in example 3.9 was P of 0 is 0.8 and P of 1 is 0.2 because 20% of all purchasers selected a desktop computer. At another store, it may be the case that P of 0 is 0.9, P of 1 is 0.1. More generally, the PMF of any Bernoulli random variable can be expressed in the form P of 1 is equal to alpha, P of 0 is 1 minus alpha, where alpha is between 0 and 1. So that means in different stores, the value of alpha could be different. That means the probability of 1 could be different. It could be 0.1, 0.2, 0.3, 0.4, 0.5, and so forth. It depends on which store we survey on. Okay, because the PMF depends on the particular value of alpha, we often write P of x semicolon alpha rather than P of x, because the value of alpha will affect the probability, Okay, so the general form P of x semicolon alpha is equal to 1 minus alpha if x is equal to 0, and alpha if x is equal to 1, and then 0 otherwise. Don't forget the last part over here. Okay, so I just want to give you the definition of the parameter of a probability distribution over here. Okay, the reason why we're talking about it here is because that the value of the parameter alpha, the value of the alpha could be different from different stores of different locations. That's why we just make it general. Okay, now let's take a look at the very last example of this part. This coming from the textbook 3.12. Starting at a fixed time, we observe the gender of each newborn child at a certain hospital until a boy is born. Okay, the boy is denoted by the capital B. That P is equal to the probability of the boys observed. Assume that the successive births are independent. We define the random variable x by x is equal to the number of births observed. Now, first of all, if the probability of a boy is observed is P, now what is the probability that a girl is observed? That would be 1 minus P, right? That would be 1 minus P. Now, so we want to find out the PMF. We want to find the PMF x over here. First of all, we want to find all of the possible outcomes of x, right? Now, first of all, x could be 1. So if x is equal to 1, we want to find the P of 1, which is the probability of x is equal to 1. X is equal to 1, that means the first observation is about P of B. What's P of B? It's a little p over here. Just add what is given. Actually, this is a little p. Now let's take a look. P could be 2 as well, right? So that means probability of x is equal to 2. So what does it mean by saying x is equal to 2? That means the first observation is a girl and the second one is a boy. So that would be probability of a girl first and then a boy. So since they're independent saying here, that would be P of a girl is observed times the probability of a boy is observed. So what's the probability of a girl is observed? It's 1 minus P. So 1 minus P times P. Of course, x could be 3 as well, P of 3. That means probability of x is equal to 3. What does it mean? That means the first 2 are girls and the third one's a boy. So that would be probability of a girl, and a boy. So which is, since they're independent, probability of girl times the probability of a boy. And then we have this is equal to 1 minus P squared times P. Because the probability of a girl is 1 minus P times 1 minus P gave us this 1 minus P squared. So what is for x is equal to 4? P of 4 is capital X is equal to 4. So in this case, we're going to have that the first 3 are girls, the fourth one is boy. So that means probability of G, and B. And then that would be probability of G times the probability of G times probability of G and times probability of B. Right? We got 3 girls. So that would be equal to 1 minus P cubed times P. Right? Because the probability of a girl is 1 minus P, and we get 3 of them. So we multiply 1 minus P 3 times, which is equal to 1 minus P cubed times P. And then, actually, we can just keep going until infinity. Okay? Now, we can put this in a general form. that we can tell that this is 1 minus p to the power of 1. So when x is equal to the power of 1 minus p is 1, so which is 2 minus 1. And when x is equal to 3, the power of 1 minus p is 2, so which is 3 minus 1. When x is equal to 4, the power of 1 minus p is 3, which is 4 minus 1. Actually, this case is 1 minus p to the power of 0 times p, right? Because 1 minus p to the power of 0 is 1. 1 times p is just p itself. Since in this case, x, the value of x is 1, and the 0 is equal to 1 minus 1, which is 0. Now we can put in a general form that the PM at p of x is equal to 1 minus p to the power of x minus 1 times p. Okay, the power of 1 minus p here is always the value of x minus 1, as based on what we get from the induction here. And of course, if x is equal to any integer greater than or equal to 1. So x is 1, 2, 3, and so forth. So this represents any integer greater than or equal to 1. And of course, 0 otherwise. So what kind of distribution does this call? This is called a geometric distribution. So we're gonna talk more about this kind of distribution in the future of this class. And over here, I just gave you this kind of idea how we get the geometric distribution and how to find the PMF of a geometric distribution. And I wish this makes sense to you. Okay, that's pretty much all about this video.